Okay, so this next problem is longest substring without repeating characters. And this is just a substring. So we have a substring here, A, B, C, A. That A just repeated. So the longest substring right there would be A, B, C. And we're not returning the substring itself, we're just returning the length of the substring. So that would be 3. 1, 2, 3. And let's see if there's any longer one. Well, this is BCA, and then the B repeats. This is CAB, so then the C repeats, and then BC, and then B repeats. So yeah, that's the longest one. The longest substring without repeating characters is 3. Here it would just be 1 because B is repeating. It just repeats over and over again. So the longest we go with just a single one that hasn't repeated, we count this B, that's 1. Then we go to the next one, that's a repeating character. So we start over. So we're going to be doing this just with a brute force method as first. So we're going to go through each index and just keep going and adding to our number until we see a repeating character. So we start with 0, which would be A at the A index. So we go to B, C, A, repeating. Okay, so now we were at 3, so the longest is now 3. And then if we find another longer one, then we start with B. B, C, A, B. That repeated. What's the length of that? It's 3. B, C, A. 1, 2, 3. That's not longer, so it stays the same. And until we go through every single one, and we just find the longest substring without repeating characters. So we're going to need a variable to track the longest, the length of the longest string without repeating characters. So we'll start with just 0, and then we'll need to go through each index. So we'll just cycle through that. We'll say for I in 0 to until the length of the S. So that will get the index of every character in S. And then, and once we get there, we need to check, we need some way of storing each character that we've seen so far so that we can check and see if we already have one. So we'll need a hash map to do that, or actually a hash set. So the difference between a hash map and a hash set is a hash set doesn't have values. It's just a set of keys, and we can check and see if the key exists already. So each one of these characters will be a key, and we can see if there's already a key in that hash set. And if there is, then that's a repeating character. Okay, so we need to import that. So, well, I guess use it. I don't know, I don't know what you call that, but it's essentially importing it. And I don't know if there's a way in VS Code to automatically import a hash set. So it looks like there's not a way to automatically import this, so you just have to type it out for now. But that's okay. So we'll create a new hash set. We need a mutable hash, and that is just going to store the character. So we'll make that a character, and it's going to store the characters that we've seen so far. And so we'll just create a new hash set, and then we'll cycle through each of the characters. So we'll get the index of the character and the character itself. We'll just call it C. And we'll need to convert the S to characters. And that will just give us like basically a vector. It's an iterable set of the characters. And we can iterate through them just like we would a vector. And we will enumerate, which will give us the index and the character. And so now we just need to see if the hash already contains the character that we're on. So hash.contains C, and we have to give it a reference. Otherwise, if we just gave it the value, that would move it out of the scope, and then we couldn't use it to insert into the hash if we did find the character. And so this also requires a hash. So let's go ahead and return this just longest. Just get rid of all these squigglies. And so if we do find it, we're going to break out of this loop. But before we do that, we need to set the new longest, which will just be J. And so longest will equal longest.max, and that's just going to, so longest.max is going to take the maximum value of the current value of longest or whatever we pass into max. So max is going to be j, and if we didn't find it, we need to go ahead and insert it in there. Makes sense, right? Insert C, and this time we are actually giving it the value, so we're passing ownership because we don't need it anymore. And what's wrong here? Oh, and then we need to convert this to an I32. Okay, so let's go ahead and try that with cargo run. And it's failing, so let's see what is failing. It's this one. And the reason that's failing is because once we get to the end of the list, we actually are not counting, we're not setting longest to the ones that we have already seen. And that's because we haven't found the duplicate character. This only checks if the hash contains the character, and if it does contain the character, we set the longest to the new set. So we actually can't really use this. We really need to check if it doesn't contain cache, and then we can just add j plus 1 if it doesn't. And we can, until we get to, and we'll go ahead and insert as well, until we get to a duplicate one, and then we'll just break. Actually, yeah, and so we're already calculating the current one we're on, the current letter we're on, instead of waiting until we find a duplicate value and setting it to the number before it. So this should be right, and we're still getting an error. Let's see, that same one. Okay, so the problem was that we haven't skipped to the letter I that we're on. So we're actually just starting from 0 each time because we haven't skipped any. So we need to skip to the current index that we're on. And so we'll skip to the I index, and that should work. All right, and it does. So now how can we make this more efficient? Well, let's go ahead and just run this in Leetcode, and we'll see if we've got the best possible solution so far. Let's see how long this takes. Spoiler alert. All right, so 400, so almost half a second faster than 5%. So we've beaten 5% of people, and we didn't use much memory, so we actually beat 100% of submissions. We even beat my efficient one because we're just using hash set instead of a hash map. So how can we improve this with a hash map though? Well, okay, so this is kind of complicated and hard to understand. So let's just take this nice and slow. I'll make this bigger. Okay, so what we're gonna do is we're gonna cycle through each one of these letters. Let's delete that. Okay, and so we're actually only gonna cycle through this one time, but we're gonna keep a hash map, and we're gonna keep a record of the last index of every single character. So when we'll go to A, we'll start with A, and we'll set in our hash map, we'll set the index of A to 0. Then we'll go to B, set the hash map index of B to 1. So because the last time we saw B was at index 1. Then we'll do the same thing for C. Then we get to A, we'll see that we already have an A, and so we will subtract the current index minus the last index of the duplicate character. So that would be 0, 1, 2, 3 minus 0, the index of A. So that would give us 3. And you can see that that's the correct length of the substring without duplicate characters. It's A, B, C is 3. Okay, so then now, once we go to B, we'll do the same thing. We see that B is at index 1, we're at index 4. We subtract 1 from 4, and we get 3. So the length from B, C, A up to the current duplicate is 3. And then once we get to the next B, but okay, let's say we had a D here. Well, let's use E just to make it distinguish it from the B a little more easily. and we have an E here. So we had an E here, and once we get to this length, so we're at B, C, A, and then we get to E, and then we see that we've got to, or actually we'll go start at A, and we'll go to E, because we'll have a repeating A there. So we can see that we already have an E, but we're starting, the new start is at A, because we already know there's a duplicate right there. So we would be starting with this B, so B, C, A, and E. And so the new substring would not include that. So we have to keep track of the start. So we have to keep track of the last duplicate index that we found too. And the new starting index will be one after that. So since we have A, B, C, A, we can start with this new B, and that would be our new starting index because it doesn't include that A. We have to include the last index that doesn't have a duplicate in there. And so then we can start. And so this would now be 4. Okay. So I'll go ahead, let's put that into action. We could change that to 4, or we could just change our code back to its original state. All right, let's just change it back. All right, so how do we do that? We need to be using a hash map now instead of a hash set. So we'll change that. And we also need to be tracking the index of each character instead of just the character itself. And we don't need this loop anymore since we're looping through each character only one time, and we need the actual character. So we can delete this up here, and that means we don't need to skip anymore. And we can use the I instead of the J because we just use the J because the I is already taken. So I is for index, and then we just go to the next letter. So now instead of contains, we're actually going to need to get the index. So we'll say hash.get, and that's going to return an option. So it's going to return none if it didn't find it, and some if it did find it. So we can use our pattern matcher if let to get the actual index. And so we'll get the index, and we'll call that one J. And so this will be the index of the last character that had the index of the last character that matches the current character we're on. So we're going to be cycling through each character. We're going to get the last one, and that's going to be stored in that hash map. Okay, so then instead of the max, we need to get the character we're on minus the start. So the actual character we're on is I. So I minus start. But we don't actually have a starting value. Let's go ahead and insert the actual index too, if we don't find it. So we can actually, this needs to go out here. So this is if we did find it, and if not, we're going to be inserting that. And so now we need to actually track the start. So since this is a duplicate character, we need to set the new start to the index after the duplicate. So let's create a new variable. We can add a new variable start, and that will also equal 0. And I don't know, this is sort of a stylistic preference to just put that on one line, but since we're just creating 2 variables, I think that's fairly neat. And so we'll set the new start to the character after this index, so J plus 1. And we also need to check to make sure that the index that we found is after the current start. And we could do and J is greater than or equal to start. So if it's equal to the start, if J is on the starting index, that would also be a duplicate. But unfortunately, Rust doesn't have that built in yet. So we're just going to have to create a separate if statement right here. And this will be basically the same thing. All right. So this should be fairly close to what we're looking for, except we're actually going to be inserting I instead of J, because j is the previous index, so this is the current index. And then we also need to get the leftover characters at the end of the string that did not have a duplicate. So like if this is BA, we need to get that BA, because there's, as of now, we're only setting longest to the max when we find a duplicate. So there could be numbers at the end, there could be letters at the end that's longer than the substring that we found that had a duplicate character. So we need to just put max here, and we will just have the length of the whole string minus 1, so that would give us the index, minus I, the current index I. Actually, we don't need that minus 1. Okay, so that should work for us. Let's see. Cannot find I, so it should actually be the start, not the I. And alright, so we've solved the problem. Congrats to us. Hooray for me. And so we will paste this in and we'll see how much of an improvement. So this is 444 milliseconds, 5%. Although we did beat 100% of the memory because we just used the hash set. So let's see. So we got 4 milliseconds and 2.2. This is less than 100%. Well, we know that's not right because I just had it. And so this alternates sort of between 4 milliseconds and 0 milliseconds. I could keep submitting it until I get a 0 millisecond one. Okay, so I just did it again, and our number was 0 milliseconds rather than 4 milliseconds, even though it's the exact same code. So looking at this guy's, he created a hash map, and he actually used the capacity, and he set the capacity initially, but I don't know, for some reason this was giving me 8 milliseconds and 2.5, so I don't really know exactly why that happened. I would think if you're not reallocating the size of the hash map, that would be faster and take up less memory, but for some reason it doesn't. Just a quirk, I guess. We'll chalk it up to a Rust quirk. Okay, so 100% fastest. Okay. Check this dude's out. So this guy's a bit cryptic, and I don't really understand his code just because he's using single letter variables, a reason why you shouldn't do that. So we're just going to ignore this one, but it looks like he knows what he's doing, but I just don't know what. So he's getting the start here as the last character, and he's saying if the start is greater than the open, then he sets the new open to this start. And then he says if I plus 1 minus open is greater, so this is the result, I suppose, is what that R is. Then he sets the result equal to basically I minus open, and then plus 1 for the current character that he's on. And so then he sets the new character. So he's doing the exact same thing we are. He's just doing it in a, I guess you could say, a better way by he's only. See, the only problem with this is he's allocating a 256 length array rather than the hash map that we're using. And the problem is you don't know, the problem doesn't say that there's only 256 possible characters. So there's a chance that if you're using Unicode or whatever, that there's going to be characters that won't fit in here, and that would error out that way. So I'm still going to say ours is better than this one, or just because it's more extensible to different types of problems. That his probably is faster than ours though, but he's kind of cheated a little bit. So this is essentially the same thing we did. Okay, so I'm happy with this, so I'll post this code online and on my GitHub, and you can use it if you want. And so, but I'm pretty satisfied with our code. So I'll post this online, and it'll be in the description of the video. And so the next one we're going to be looking at is number 4, and it's the median of 2 sorted arrays. And this is a hard one, so this is our first hard problem. Pretty exciting, y'all. Okay, see you next video.